Assalamu alaikum students. The topic of today's lecture is significant figures, in which we study what are the significant figures, why these are important for taking correct readings. This is very important point. And then explanation of the rules for finding the significant figures in a measurement. So these are the objective of our today's lecture. So let's start. Now first of all, we will define what are significant figures. So all accurately known digit and a first doubtful digit in an expression is called a significant figure. Now, accurately known digit and a first doubtful digit during a measurement. As we studied in measuring instrument, that we are taking measurement by using some measuring instruments, and each measuring instrument has a limited value which is called its least count. So by using this least count, we come to know how many digits are accurately known and how many digits are doubtful. So this is how it tells us about the precision of an instrument. So we see why significant figures are needed, as significant figures are important to show the precision of your answer, how much precise you are in your answer, or how much precise your instrument is. It is you know by knowing the significant figures. So this is important in science and engineering, because no measuring device can make a measurement with 100% precision. So significant figures allow the scientist to know how precise your answer is or how much uncertainty is. So as a general rule, more significant figures means more precision. For example, a student measures a length of a book as 18 centimeter using a measuring tape. So now measuring tape is a length measuring instrument. So the number of significant figures in his her measurement value will be R2. Now you see, the first left digit 1 is accurately known because it is accurately, and while 18 is a doubtful digit for which the student may or may not be sure. Maybe when he measured again, maybe it says it is 17, or may it says it's 18 or 19. So 1 is the accurately known digit, while this 8 is called doubtful digit. So it has two significant figures. Now another student measured the same book by using a ruler. Now when he or she uses a ruler and claims its length to be 18.4 centimeter. Now in this case, you see, there are three significant figures. Why there are three significant? Because we are 2 are accurately known digit, 1 and 8 an accurately known digit, and the 4 is doubtful digit. Now because this instrument can measure up to 1/10 of the centimeter, that is why we can say that 18.4 is correct, because 0.4 is the 1/10 of the centimeter. So left two digits 1 and 8 are accurately known digit, and next 4 is the doubtful digit for which the student may or may not be sure. Maybe next time when he or she measures it, she says that it will be or 18.5. So after this point, he or she may not be sure. Now a third student records the length of the same book as 18.425 centimeter, and you see, he or she made this measurement with the same ruler. Now number of significant figure is again 3, as we discussed earlier that a meter ruler can measure only 1/10 of the centimeter, not 100 or 1000 of the centimeter. So these two values 2 and 5 are not significant because our instrument has a limitation. So this is, you see, as we discussed in this slide, that significant figures are important to show precision of your answer, or it tells us about our instrument. So you see, why we are not taking these two values 2 and 5 because our instrument cannot measure up to 100 or 1000 of the 100 and 1000 of the centimeter. That is why these are not significant, but 18, 1, 8 are accurately known, and this 4 is doubtful digit, so they are called significant figures, while 2 and 5 are not significant figures because it cannot be justified by using the ruler. Is it clear? So let's see. Okay, now let's move towards the rules to find the number of the significant figures. So in general, all non-zero digits are always significant. In general, of course, when we are finding the number of significant figures, we must know about the instrument. But in general, all non-zero digits are always significant. Now, zeros are very important. Zeros may be significant, may not be significant. Remember this point. So when zeros are significant and when zeros are not significant, we must know these rules. So zeros between two any significant numbers are zeros. Zeros between two any significant. For example, I am writing, let's suppose 2, 0, 2. Now it has three significant figures because now this 0 is between two significant figures or two non-zero numbers. So this 0 is significant. Now final 0 or ending 0 on the right side of the decimal are also significant. Let's suppose I am writing 210.0. Now it has significant figures equal to 4. Okay, now it has a significant figure equal to 4 because now these two zeros are also significant. They are on right side or ending on the decimal fraction, so they are also significant. Now zeros on the left side of the decimal used for the purpose of spacing are not significant. Remember this point. For example, I am writing a number like 0.0028. Now significant figures are, SF stands for significant figures. Okay, so significant figures are only two. This 2, 0 and this 0 is not significant. Only 2 and 8 are significant figures. Okay. Now the last rule, in a whole number that ends with one or more zeros without a decimal point, these zeros may or may not be significant. Now let's see what is the meaning of this point. For example, I am writing a number, let's suppose 2500. Now these two zeros, as it has no decimal point and they are on the right side, these two zeros may or may not be significant. Now when they are significant, it is not clear which zeros serve to locate the position value and which are actually part of the. In this case, we write this number into a scientific notation. So when we writing in a scientific notation, we write 2.5 into 10 raised to power 3. So now here it is a point. So now significant figures are only 2, not 4. Okay, so these two zeros are skipped from the significant figures. So when we have this type of number that ends with the zeros without any decimal points, we must convert this number into scientific notation, and then we see how many numbers are there with the power of 10. This shows the number of significant figures. Okay. Now these are also the rules for finding the significant figures in short. This is just a summary. Now digits other than 0 are significant, like 27 has two significant figures and 275 has three significant figures. Now zeros between significant digits are also significant, like 2705. Now this 0 is in between these two significant figures, so it has 4 significant figures. Now final zeros or zeros after the decimal are also significant. So this 275.00, this is a point, and 00, these two zeros are between, these two zeros are after the decimal point, so they are also significant. So total number of digits, significant digits, are 5. Now zeros used for spacing in a decimal points are not significant, like 0.03. These two zeros are used just for spacing. Similarly 0.027, these two zeros are used for spacing. Only 2 and 7 are significant figures, so it has only 2 significant figures. So these are the summary of the rules that we learn in this topic. Okay, so these two zeros are not significant because they are on the left side before, they are on left side. Okay, and then this 2 is significant, and this 0 is also significant because it is between the two significant numbers, and this is a final 0, so it is also a significant. We have 4 significant numbers, and while these two zeros are not significant. Okay, now let's see the example 1.4, which is given in your book. Find the number of significant figure in each of the following. So 1.008. Now you see it has 4 significant figures. Why it has 4 significant figures? Because these two zeros are between two significant number, two non-zero numbers. So that is why it has 4 significant figures. So all 4 digits are significant. The zeros between the significant figures 1 and 8 are also significant. So if we write in scientific notation, we can write 100.8 as 1.008 into 10 raised power 2. Similarly, when you see, when we convert this number into scientific notation, it also has 4 numbers multiplied with the 4 digit number is multiplied with the power of 10. So these 4 are significant. Similarly, in second example, you see these two zeros are not significant because they are on the left side of the significant numbers, and there is no significant number on the right side of these two zeros. So these two first two zeros are not significant. Okay, and they are used to space the decimal point, as we see in here that zeros used for spacing, here zeros written on the left side of the decimal use point for purpose of spacing are not significant. That is why these two zeros are not significant. So if we write in scientific notation, when we move this point after 5, so it will be 5.80 into 10 raised to power minus 2. We already know how we can convert a number into a scientific notation. We already studied in the previous lectures. So as 3 digit number is multiplied with this power of 10, so it has 3 significant figures. Now 210.0, the final zeros is a significant since it comes before the decimal, after the decimal point. So if we see this point, that final zeros or zeros after the decimal are significant. That is why we can say that this zero is also a significant because it is after a decimal point. So when we write it in scientific notation, we move this point of before 1 and after 2. So it will be 2.100 into 10 raised power 3. So it has 4 significant figures. So I hope you understand how to count a significant figures. Just remember these rules to know that how to find a significant figures. So this is all about today's lecture. So thank you very much.